Okay, so I found this from like a very old book. It's not even a book, it's just some pamphlet on popular maths. Uh, it is by some government school teacher in Tamil Nadu. This was written in like some 1990s. So he was like showing some tricks for multiplication, like multiplying by 11, multiplying by 111, and so on. But there was like one thing very interesting, which I thought like I will share with you. So, okay. Uh, Hari, give me some three-digit number.
124.
Okay. So, Gauri, give me another three-digit number.
371.
Okay. So now we have to multiply these two numbers.
Oh no.
No, wait.
Okay.
So I will do it on calculator only. So 124 into 371. Okay.
The last
So the
digit should be
answer
4.
is 46104. Okay. So now, how do we check if this answer is correct or not? Okay. So the method that this guy tells in his book is that we will take the sum of digits of everything. So I will take the sum of digits of 124. That will be 7. So
Oh,
sum of digits of 371 is going to be 11, which is again equivalent to 2. So now I will multiply these two.
wow.
7 into
Odd 9.
40, which is also equivalent to 4. So now I will multiply. I will find the sum of digits of these 5 digits and see if it is same as 4. So 4
My
plus
God.
0 plus 4,
Oh my God.
15. So it is not coming out to be correct.
Oh.
So now if I add the digits and if it is not the same, then I can say that I have made a mistake over here.
But the converse will not be true.
But the converse is true. That is, so the correct answer turns out to be 46004.
But what Shravan meant was you could have increased
So if the answer we wrote was
5.
46400, so it has 1 in 9.
Comes out to be correct.
Yeah.
So basically
Still,
what
it's
we are
a
doing
good
is sum of digits into sum of digits.
Yeah.
So yeah, will this work
Oh.
all the time? Why should this work?
So this is mod 9.
Correct.
Correct. It won't work all the time.
Okay.
No,
Can you
as
give an
in-
example where it won't work?
So if the product was, if we had written it as 46400, then it will still tell that if you just check the digit sum, then it shows that it is correct, but the product is not the same.
No. So this is the correct answer for this multiplication.
Yeah.
So here if I take the sum of digits,
Ah,
it is coming out to be 7.
okay.
Here sum of digits equal to 11, but which is same as 2. So 7 into 2 equal to 14. That is the sum of digits of this number. So it is working out in this example.
No, I'm saying
I
if we had
think
wrongly written the product as 46,400
46.
or 46,040.
Correct.
No,
Then it will.
converse is not true. That is what he's saying.
Correct. Yes. So
Converse means like if this is
No, if its sum is matching,
Sum
we
is
still
same,
can't be sure.
that doesn't mean that that is the product.
multiplication
That
is
is
correct.
fine.
Yes.
Okay.
Correct. Yes.
It is other way around.
If it is wrong, we can say something is wrong.
Correct. Yes.
Okay.
Yeah, means if you can, for counter example, you need a product where the sum is not same as this. Means that way we can say that this statement is wrong.
Correct.
So we can make it stronger by doing one more test. Say 10 and 5 are weak. Maybe 11.
10 and 5 are weak.
As in,
No.
No, for
Uh,
anything,
but
this will be the problem, no?
yeah, but if you combine two
Ashwin,
things,
this is true only for 3-digit numbers, is it? Or for even 2-digit or
Huh,
3-digit and
it's
2-digit or something
any
like
digit
that?
number, even
So
2
why
digit,
don't
4
we
digit.
try for 2-digit? I mean to start with 2-digit, then 2
Yeah,
and 3-digit, something like that.
yes, yeah, we can try for 2 digit. So give me some 2 digit number.
Maybe 81.
Okay, Shravan, give me a 2 digit number.
71.
Okay, so the sum of digits of this is 9. Sum of digits of this is 8. So I'll just multiply these two, 9 into 8, which is 72.
72, and the
So here
sum is 9.
which I can like further simplify to 9. So 5 plus 7 plus 5 plus 1 is equal to 18, which is again, I will just add the digits again over here to get 9. So if I reduce it, this also comes to 9, and multiplying these two also gives me 9. So yeah, I can see that, yeah, I have multiplied correctly. So yeah, as Shravan pointed out, even if I had got the answer like something like 5841, this will still have the same sum of digit as 9. So it is like, just because these two numbers are same doesn't mean that this answer is correct. But if this answer is, if the sum of digits is like not the same, then I can for sure say that I have made a mistake while multiplying. So, yeah. So why will this method work?
Yeah, in modular arithmetic principles, if we use, we'll get it.
Correct. Yeah. So now it's a question of like checking whether that modular arithmetic is like valid, how it works. Yeah. So basically, we are claiming if A into B equal to C, then sum of digits of A into sum of digits of B equal to sum of digits of C. So this sum is like I want to bring it to a number between 1 to 9. So it's like if this sum is like some 2 digit number, we will take sum of digits of that. So it's like I am always like reducing the sum of digits so that I get a single digit Asyam. Who is like not comfortable with modular arithmetic and like who like cannot see why this will work, right? So it's like
I can't see why this will work.
oh fine. So yeah, then we can discuss about
And it's more easy to divide and check, no, rather than doing this.
divide means you want to like divide this 46,000 by 124 and check.
Yeah, one of them.
Correct. Yes, we can do that also, but that is like a more cumbersome, long process. This is like a quick shortcut to check. This is not like 100% guarantee check, but this is like much faster to do.
So
I
it's a
feel
mod.
before going further, it will be good if, yeah, some of us might have explored, but if others, if we can explore the digit sum, there are some interesting patterns in digit sums that will help us in understanding this also. Say, for example, the number 75 as digit sum of, if we add the digits, we get 12.
Well,
And
Oh,
then
so
if we
12.
further add it, we get 3, right? So the digit sum is you keep adding the number repeatedly till you get a single digit number. So now try to find some numbers whose digit sum is 3 from
30.
1 to 100.
30,
30, okay.
12, 84,
Nice.
4, super.
66.
93.
6, 9.
66.
Okay, so
Hmm.
now you can consider this question. How many
Yeah.
such numbers are there?
Try to list all of them.
633, 633.
So we'll focus on 1 to 100 first. Then we
Okay,
can go to
okay.
others.
Okay, okay. Oh, how many numbers between 1 to 100?
With digit sum 3.
Yeah.
So we'll start with 3.
Uh,
It's basically every third multiple of 3, no?
yeah, yes.
Third multiple.
But yeah, see, we can find some other patterns also. Yeah. For now, I think your observation is correct. We will see, I mean, we'll verify it together.
So 9 is a third multiple of 3.
No, first will be the fourth, afterwards 3 more, like every 3 more.
Starting from 3 every third multiple.
Okay.
Yeah. So would someone like to share some numbers which have digits sum as 3?
11, all of them.
No. So if we take 11, it will be 1 plus 1. So digit sum of 11.
No.
Total count, I guess.
Total
Oh.
count 11
Okay.
from 1 to 100.
Okay. So yeah, 11 is not such a big number. So can we list out all the numbers?
Yeah, 3, 12, 21, 30, 39, 48, 57, 66, 75, 84, 93. 3 means every number is differed by 9. As she said, third multiple of 3. Every third multiple of 3.
Okay. So is there any other pattern that you see among these numbers?
That you are increasing, reducing one digit and increasing the next digit by 1.
Right.
Right. Okay. So tens digit increases by 1. Ones digit
Decreases by 1.
But there will be a problem when there is 0 as the last digit. So there you are having this jump that is from 30 to 39. But apart from that, yeah, it's following this pattern. Yes.
Yeah.
So one pattern I see is that if there is a number of the form AB, then BA will also be there in that. BA will also be there in the list.
Yes. Like 12, 21, 0330, 3993 and so on.
Correct.
Yes. Because ultimately it's a sum.
Correct. Yeah. So because like addition is commutative, so it doesn't matter in which order you add. So that is another observation. Anything else that we can see?
So one more thing is, since we are talking about the sum should be 3, and because of the divisibility rule of 3, all these numbers are, any number should be a multiple of 3.
Nice.
We have at least one number. What can we say from each tens? Starting with 0, then 1, then 2, then 3.
Okay. So you are saying
for 30, 39, we have 2.
Every set of 10, like 1 to 10, 10 to 20, like that, has at least one number.
At least one number.
Very nice.
For the 3-digit numbers from 100 to 200, we have 11. And then in the next, from 200 to 300, we have 12.
Okay.
And one observation we can say that here we start with 3 from 1 to 100. For 100 to 200, we will start with 2. 102.
Okay.
And so on. And there we end in, instead of 93, we will end in 192.
So yeah, it will be like 102 and so on, and it will end with what?
192. Here,
okay.
the ending last digit was last number was 93 in 1 to 100. Then from 200 to 300,
okay. So
it starts with 201.
Yeah, but interestingly, but I thought the number should be the same. It's like I am increasing the hundreds digit by 1. That means one of the things, if I reduce it by 1, essentially the count, the feeling should be
So
same.
I think that's what happens in 102, no? So it's like 003. I'm increasing 100 by 1 and decreasing the units by.
Right. So basically, I should be able to map every 100. Every 100 to every 2-digit, every 3-digit number to every 2-digit number, and I felt the count should be the same. But it is interesting to hear that it is not the same.
So this is similar to how in the 30s range there are two numbers, 30 and 39, whereas every other range had one.
But what is the extra thing here?
No, the change is 201 to 300. We have one extra. It
Which is
starts
that
from
extra?
101, sorry, 201, and it ends in 300.
Or maybe that last one is like an extra.
It would have been 291, and
Huh.
we are also having 300.
Oh,
Because that
300
9 becomes a bonus
difference.
there.
It's same, no? In every decade, there will be either 3 or 4 multiples of 3. 10 consecutive numbers. You will find either 3 multiples of 4 or sometimes 4 multiples
Four
of 4. So 4 multiples of 3, sorry. 3 multiples of 3 or 4 multiples of 3.
And not of 4, right? 3. We are talking about 3 or 4 multiples of 3.
Yeah.
ah,
But if we take a perfect divisor, say for example 5, if we're looking at multiples of 5, there'll always be only 2 multiples of 5 in every 10 numbers.
So if we look at every 12 numbers, then multiples of 3 will be.
Yeah, correct, exactly.
Okay, so Shravan, you're talking about 12 consecutive numbers, is it?
12 consecutive numbers, yes.
Right. Okay, so what is your claim?
In any
No,
12
I made the
consecutive
statement.
numbers, there will either be 3 or 4 multiples of 3.
Always 4.
Oh,
no?
there'll always be 4, no? Correct. Or wait, no. If
wait,
if it starts from,
If
say
it
for
starts
example,
from 1 to 12, or 2 to 12, or 3 to 12.
2 to 13, so no, yeah.
consecutive, like,
13
yeah,
and
13.
It'll still have 4,
3,
8, and 12 only. 4 to
2 to 13 also 12 is there.
Also, is it possible to find out for how many number of digits, how many steps we have to come down to get 3?
This is a nice question.
What?
But that's not possible, no? I mean, yeah, it's a thing to try.
4 to 15, we have only 3, right?
4 to 15. 15 is also.
15 is also there, na?
Hmm.
Oh, 15 is also there, yeah.
Yes.
Everywhere it's 4.
Yes.
Nowhere
Yeah.
it is 3.
9, 12, 15.
correct.
4 to 15, 3 to 14, 2 to 13, 1 to 12. So everywhere we have 4.
There are 4.
Yeah.
4, yeah.
Right. So is this clear to everyone? It's like, is there something else you want to discuss about this?
Well, this is clear. This is clear for me.
Okay. So I mean, then I can like give a more generalized claim. So if I take every n consecutive numbers, how many multiples of k will be there?
N by k.
Uh,
For any k, for any n.
but n by k might not be a whole number, right? So what if your n is say 25 and k is some, yeah, say 7?
If k divides n, then the answer will be the quotient.
Okay, if k divides n, then it is n by k. Okay.
N by k.
So you have to bring in a new, like, not constant, I can say. One a, for example, it is n is equal to k into a.
Then
If
in
n
that
is equal to
case,
k into a, then it is n by k. If it is n is
by
equal to
k
k into a
minus
plus
1.
1,
Just
so
one less, right?
depending on what k is. If k is 100, we cannot go on writing up to 99.
So it is like, so now it is like we want a formula where it will be independent of k. So so that you don't have to worry if k is 1, 2, or n is of the form some multiple of k plus 1, multiple of k plus 3. So we want to come up with a formula that will be like general formula, and it is not dependent on what the value of n or k is. So can we find a
But will
formula?
this work, Ashwin? N upon k minus 1? Just one less than the
Okay.
earlier case?
You are saying like this?
Yes.
Okay. But again, so if k does not divide n, this will not be an integer. Yeah, this is not a whole number.
So, okay. That's where that.
So we take only the whole number part. We do not take the factor part, fraction part.
Okay.
So for example, if it is 11 divided by 3,
Hmm.
then
3 threes are 9, 3 point something. So 3.
3 point
would be
something,
the
right?
answer.
So we take 3.
3.
Right. So
One hint is just write the sequence of number of multiples, maximum number of multiples. I think that should give some hints.
Maximum number of multiples.
Yeah.
Means I didn't understand.
So for example, for 11, it is either 3 or 4, right? So you just write the maximum possible. Yeah. So for example, let's say from 1 to 20, we can just write what is the maximum number of multiples for those many consecutive numbers.
So, Shravan, what do you mean? Like from 1 to 20, you are taking k is equal to 3, is it?
No, say for example, if we take one number, it can either be a multiple of 3 or not. And if we take two consecutive numbers, we can at max have one multiple of 3. And if we take three consecutive numbers, we can have at max one multiple of 3. Whereas if we take four consecutive numbers, we can have two multiples of 3 at max. And if we write this sequence, there is a pattern.
So what he is saying is, if you take just two consecutive numbers,
Okay, maximum number. Okay. Okay.
it will be like 3, 4, or like 17, 18. At max, there can be
1. 1. Yes.
If you take three
Three
consecutive
consecutive numbers, 1. So
Yeah.
the difference is that in two consecutive numbers, you may get 1 or 0 also. Maximum will be 1, but in 3, you are sure to get 1.
Yeah, that is the difference between 2 and 3.
That
Yes.
is difference between 2 and 3, right?
Yes.
Correct.
So 2 may maximum will be 1, but yeah, minimum could be 0 also, right? But 3 may will be definitely 1.
The possibilities are 0 and 1, but maximum will be 1. For this also 2. No, how can it be 2?
Okay, so I will add something for maximum and
yeah.
6, 7, 8, 9. No, see, Shubhangi, 6, 7, 8, 9.
Yeah,
there are
yeah,
two.
yeah. 12, 13, 14, 15 here.
If you start from a multiple and go for
then,
numbers, then you will have 2.
Right.
Right. So yeah, I mean, we will just like find a pattern over here for just 3 only, and see if we can extend it for like bigger numbers.
So then we should extend it for any k, right?
Yes.
So for 4, it has to be 1, 2 and 1. Minimum will be 1.
Yes.
And for 3,
what should it be?
minimum also 1.
Yeah. For 5.
For 5, 2, maximum 2, minimum also 2. 13, 14, 15, 16, 17. No, minimum will be 1.
Minimum will be 1.
1. So
1,
maximum
2, 3, 4,
will
5.
be 2
1, 2,
and
3, 4,
minimum
5
will
may
be
1.
1. And now
6
for
may it
this,
will be
2,
2.
2. 6 ke liye 2, 2.
You're talking the minimum?
Yes, both.
Okay.
3, 2. 3, 2 for 7. 3 is there, maximum.
Minimum 2. Minimum is 2. 1, 2, 3, 4, 5, 6, 7, 8.
2.
So 2.
3 and 2, same thing. 3, 2, 3, 3. Now, as soon as you reach 9, so as soon as you reach another multiple of 3, you hit the next maximum, minimum becomes same.
Okay. But
so 12 may it will become 4, 4.
But right now, this is
my
like,
hypothesis.
Yes. So is there a proof for this? So like our claim right now is that when you take any like multiple of 3 consecutive numbers, 3, 6, or 9, the maximum and minimum is the same. That's our claim. Right?
And it will increase by 1 as compared to the last multiple.
Okay. Yes. So we can like add that also.
So will it increase?
It is increasing by 1, no?
Only the minimum is increasing.
Yeah, the minimum. So yeah, the minimum is increasing by 1. Maximum is not increasing. The maximum is staying the same.
So if we look at this, can we come up with a generalization for non-multiples where k does not divide in?
So it looks like minimum is a kind of just a shift of the max multiple. But I think Gauri, that's what you were saying.
It's like it comes here and then it shifts. Then it comes down and then shifts.
Okay, just tell me if this is fine. N minus k by k plus 1.
N minus k by k plus 1.
Plus 1 is like that is a different thing. Plus 1 is not included in this.
Right. So
N
like
K.
this is
I'll just show the wait.
Oh.
How does it matter if it is maximum or minimum? It is just
Because
one just
they're
same number.
no. Because Srilata, see if you see the table, right? In the table, if it is not divisible, if n does not is not divisible by k, then the maximum and minimum values differ.
Okay.
They are not the same.
So as you are telling, it will be like either 4 or 5 or 3 or 4.
Yes,
In that
yes, or 2 or 1 or something like that. Yes. So if
it's always one apart, is it?
One apart, yes. If it is not divisible. So I also have something. Okay. If it is not, so if it is divisible, we have n divided by k. If it is not divisible, then the whole number part of n upon k. If the minimum will be the whole number part of n upon k, and if the maximum will be the whole number part of n upon k plus 1.
If it is not a multiple, you are saying it's whole number part plus 1, right?
This is the maximum. And the minimum is whole number part only.
Okay. Right. So this whole number part of a number of say any number x, that is denoted by this symbol. So this is called the floor function.
Oh, okay.
This is like a standard notation. Basically, if you have some number x, the whole number part of x, which is denoted by this, which is also called floor of x, is basically the greatest number less than or equal to x. So similarly, there is another function called ceiling of x, which is denoted like this. That is just the top part of the square bracket. So this is basically the smallest number, whole number. So it is the smallest number that is greater than or equal to x. So what we saw here was
the minimum will be the ceiling of k, no, of n upon k.
Okay.
The ceiling, sorry, the floor of n upon k.
Correct. Yes.
Okay. The floor of n upon k is the minimum is the minimum number of multiples of k.
Correct. Yes.
Okay. And the maximum number of multiples of k will be the floor of n upon k plus 1.
Yes, this is clear.
So, for example, will this be floor of n by k plus 1, or will it be ceiling of n by k? I mean, which of these two will it be?
So minimum minimum multiple will be the floor, and the maximum multiple will be ceiling. If
no, not necessarily, Mega.
If k is not divisible by n, isn't it? Isn't that what we just said?
If k is not divisible by n, then is it always true that we will get 4?
Sorry, n is not divisible by k. Sorry, isn't that what we just saw? I mean, at least from the table, that is, I don't know how to prove it, but in the table, that is what I'm seeing. So if we look at the first example now, the first number is 1, that is n is 1, and k is 3, right? So the floor is 0. That is why the minimum is 0. Okay. And the ceiling is 1. That is why the max is 1. Similar, the same case is with the 2 also.
I'll just paste it over here.
Okay. Okay.
Yeah, good.
Yeah. So if you look at the second example, again, n is 2 and k is 3. 2 is not divisible by 3. So your minimum is the floor, which is 0, and the maximum is the ceiling, which is 1.
Correct.
Both the cases 1 and 2. The 3 again, 3 is divisible by 3, so that will not apply. It is directly n upon k. In this case, 1.
Yeah. So what happens? So the thing is, I want to point this out that both these answers are correct. That is floor of n by k plus 1 and ceiling of n by k. So they both mean the same thing in this particular context. Can you see that? Okay. So now, for example, can you tell me what would be, I mean, how many multiples will we have if we take, say, 47 consecutive numbers? What will be the max and what will be the min?
47 for 3, right?
Huh.
So 47 divided by 3. So minimum will be 15 and maximum will be 15 plus 1, that is 16.
16.
And for 48, this will be 16, 16, right?
Correct.
Yeah, because it's divisible. Correct.
Yes.
Yeah. And for 46, this will be again 16, 15.
Correct. Yes.
And for 45, it will be 15, 15.
Correct.
Now it's
Yes.
58.
Yeah, anyway, so I mean, we started somewhere with like sum of digits, but yeah, we ended up with like the floor and ceiling function. But anyway, so this is like yeah, so this is useful sometimes in like computer science also. That is this floor and ceiling function. But otherwise, I can see it used in like a lot of combinatorial expressions, like this question, like how many multiples of k will be there, and so on. So yeah, so this notation is sometimes used in like combinatorial. If there is like nothing further to discuss, maybe we can wind up for today.
Yeah.
Yeah.